We are looking at a basic differentiation formula for trig function. I'm going to prove a few of them. Okay. Derivative of sine is cos x. Derivative of cos is minus sine x. Derivative of tan, I'm going to prove that for us, is sec square x. For derivative of tan x will be d dx of sine x over cos x. And this we call for quotient rule, and that will be cos square x square the denominator, okay, and then the denominator times derivative of the numerator, which is what, cos x, then minus the numerator times derivative of the denominator minus sine x, and that will give us a cos square x minus minus, that's plus sine square x all over cos square x. So from identity, from trig identity, cos square x plus sine square x is 1 over what? Over cos square x. And note, 1 over cos is sec x. Okay, so in that case now, the differential coefficient of tangents of tan x, it will be what? Will be sec square x. So that one is done. So let's go to differential coefficient of cot. Cot is the inverse of tangents. So that will be cos x over sine x. Okay, so this is a quotient function, and that will be equal to what? Sine x squared, sine x. Derivative of this one is minus sine x minus the numerator times derivative of the denominator minus sine square x minus cos square x all over what? Sine x all squared. So you can factorize minus so that we can achieve the identity. So that will be sine square x plus cos square x all over what? All over sine x squared. And don't forget, sine square x plus cos square x is 1. So I'm having minus 1 over what? Over sine square x minus CSC square x, which is minus, you can call it minus cosec square x. So the choice is yours. They are the same thing. So we've confirmed this. The derivative of cot is what? Is minus CSC square x. Okay, let's go to derivative of sec x. That will be dx of sec x. And don't forget, sec x is 1 over cos x. So this is also a quotient function. Apply your quotient rule. So that will be cos x here. Derivative of numerator, derivative of 1 is 0 minus the numerator times derivative of the denominator minus sine x. So this one is gone. I have sine x over what? Over cos square x. I'm going to do something here. This is double. So that will be 1 over cos times sine x over cos x. Just split this one into 2 parts. So 1 over cos is what? Is sec x. Sine over cos is tan x. So derivative of sec is sec x tan x. Then the last one, that's the derivative of cosec x. So let's quickly do that. d dx of CSC, which is equal to d dx of cosec is 1 over sine. That's 1 over sine. And if you apply your quotient rule, that will be sine x squared, sine x. Derivative of numerator is 0, then 1. Derivative of the denominator here is what? Cos x. This one is gone, that's 0. So we have minus cos x over what? Over sine x, sine square x. So we can split this one into 2 parts. So that will be minus 1 over sine, and then times cos x over sine x. So 1 over sine is what? Cosec x, and then cot x. Okay, actually, most standard exam will give you the list of this formula. But if you are not given, I think you can generate for yourself. You can generate for yourself, or you memorize it. So that's just that on that. The next thing we want to see now, want to see how we can apply this for both product rule and quotient rule. So we're going to combine both product rule and quotient rule together. So let's see questions on product rule and quotient rule. Don't forget to click on watermarks on this video and subscribe. Click on like button and begin to put your comments through. Type your comments. Finally, share the links of this video on all your social media platforms. And again, if you need one-on-one or group discussion, okay, on your Calculus 1, you can book appointment with me. Okay, questions on product rule and quotient rule. Let's go there. We have the following question: find the f dt function, and we have the 1 and 2, and we have the third one. So let's go straight to the solution to this question. If you look at it now, our function is a function of t, and that's why the question says the x dt. So that will be equal to, this one involves product rule. So I'm going to differentiate the first one and keep the second one constant. Keep this one constant, differentiate this one, then plus. Now keep your first one, keep it constant, differentiate your cos t. That's minus sine t. So that one is done. Then here also is also a product rule. So there's minus there. I'm going to open the brackets. So this is going to be, I'm going to take this one as the first one, 12t. That'll be 12. I'll keep the second one constant, then plus. I'll now keep the 12t constant now. I will now differentiate the sine t, which will be cos t. Close your brackets. And finally, this one, 12. If you differentiate cos, you're going to give you minus sine t. So this is a constant. So minus minus, that's a plus. So that's a plus 12 sine t. So that's that. The other thing is just the algebra. Do the algebra. So that's that on that. The second one, we have going to find the x dt. So the first one, t5, that will be 5 t to the power 4 if you differentiate that. And then to differentiate CSC, cosec is minus CSC tan t. We just finished the table, and then derivative of a constant is 0. So that one is gone. So we can just open the brackets, and we have this plus this tan t. Okay, on the final note, the third one, the y prime will be equal to, if you differentiate this, you can do the algebra of this one, and that will be 8x minus 1. Okay, that's the algebra. If you differentiate, that will be minus 8x minus 2, and that's what? Minus 8 over x to the power 2. Okay, then plus. If you differentiate sec, that will be what? That will be sec x tan x. The best way to really comprehend this segment is to practice as many questions as possible, and that's what we are doing on this channel. Find the y dx if y is equal to this. Okay, so without wasting time, I'll go straight to the solution. This one is a product, so I'm going to keep this one constant. I'm keeping sec constant, and then I'll differentiate tan x. I'm using prime for ddx of tan x. Then plus, keep your tan constants and differentiate sec x. I'm using prime also on that. That's a ddx of sec. Then plus, it's also a product rule. Differentiate that. That's a 12x cubed. Keep the constants. Then plus. Now keep this one constants and differentiate your cots. If you differentiate cots, that will give you minus CSC square x. Okay, so then you're going to have sec x. The derivative of tan is what? Is sec square x. Then plus tan x. The derivative of sec is sec x tan x. Then plus 12 x cubed cot x. Then plus minus, that's minus 3x to the power 4 CSC square x. So that's that on this question.